Hey everyone, and welcome to today's Explainer. I am so pumped to dive into this with you because today we're going on a journey. We're moving from feeling completely overwhelmed by AI to totally mastering it for your everyday tasks. We hear so much high-level theory about artificial intelligence, but today we're grounding it. We're going to look at the practical, under-the-hood mechanics of how these systems actually work, and more importantly, how you can command them to literally save yourself hours of tedious work every single week. But first, I need you to be honest with me for a second. Are you still treating AI like a polite human or a traditional search engine? Because this is a massive pain point for so many of us. You type in a polite, vague question, kind of the way you might ask a coworker, or maybe you just type in a few choppy keywords, and what do you actually get back? Confusing, messy, spaghetti results. It's super frustrating, right? But here's the secret. It's not because the AI is broken. It's simply because we aren't speaking its mechanical language. Okay, so here's our roadmap for today. We'll cover 1, the AI automation revolution, 2, under the hood RAG search, 3, agentic multi-step reasoning, 4, the boss versus beggar, 5, pro prompting hacks, and finally 6, the no-code pipeline. Let's jump right into section 1, the AI automation revolution. We are living through an absolutely massive paradigm shift in how we find information online right now. And understanding this shift, that is step 1 to taking command. Think about it. For decades, we've relied on traditional search engines. They crawl, they index, and they basically force you to wade through an endless sea of blue links and pop-up ads just to piece together your own answer. But now, we've entered the era of answer engines. Think Perplexity, Google Gemini, or ChatGPT search. Instead of giving you a list of homework to do, these engines synthesize facts from multiple websites and write out a cohesive, natural language answer for you, immediately. Moving on to section 2, under the hood, RAG search. So you're probably wondering, how exactly do answer engines pull this off? Well, they use a clever 3-step process called RAG, which stands for Retrieval Augmented Generation. Think of this as a dynamic bridge. It lets the AI pull live data without having that data permanently baked into its training weights. Step 1 is live web retrieval. The AI translates your query and silently gathers the top 10 to 15 ranking web pages. Boom. Step 2 is vector context packing. The system ruthlessly strips away all the HTML junk, the sidebars, the ads, turning those pages into clean text blocks. It uses embedding models to extract just the most relevant paragraphs. And finally, step 3 is prompt conditioning. The system literally appends these paragraphs to your prompt as the ground truth. The neural network then synthesizes its answer based only on that retrieved text. Now, why does this matter to you? The absolutely crucial point here is that by forcing the LLM to place a citation number next to every single fact it claims, you can verify sources instantly. This is your ultimate truth guard. You see, traditional chatbots are prone to hallucinations. They confidently make up believable facts just because they're essentially predicting words. But answer engines, they are grounded in live retrieved URLs. You verify the sources on the fly, which protects your everyday decisions from AI just confidently making things up out of thin air. All right, section 3, agentic multi-step reasoning. Now that we know how a single search works, welcome to the wildly cool world of agentic multi-step reasoning. A quick search is just a single loop, right? Query, search, summarize, done. But a pro search, that acts way more like a human research assistant. Say you ask a multi-layered question, like, find me a hotel under $200 with a gym that has availability next Friday and is near a highly rated bakery. A standard search completely fails at that. But Pro Search decomposes your prompt into individual tasks. It executes a search for the hotel, analyzes the output, triggers a second search for availability, and then a third search for the bakery. It loops all these multiple tasks together in the background so you don't end up with 20 open browser tabs. Let's ground this abstract tech in some really relatable daily chores. Take travel. Instead of clicking through 30 different travel guides, just tell the AI to plan a Tokyo itinerary and group it geographically. Bam! You just save hours of backtracking on trains. For product research, ask the AI to compare the decibel levels of dishwashers under $800 by searching consumer forums. That instantly bypasses all those sponsored mommy blogs. Or honestly, my favorite, the tech fix. Tell the AI your washing machine is throwing an E15 error code and ask for the exact tools and step-by-step instructions from the official manual to fix it yourself. You are literally reclaiming hours of your life with these agentic searches. Which brings us to section 4, the boss versus beggar. Okay, we've talked about how the machine searches. Now we absolutely need to talk about how we actually speak to the machine. I call this the boss versus beggar paradigm. Underneath the hood, large language models aren't thinking the way you and I do. They rely on next token prediction. That's a probabilistic process where they generate text by predicting the single most likely next word based on massive probability tables. So if your input is vague and polite, that probability table is wide open. And that naturally leads to those scattered, inaccurate spaghetti outputs we talked about earlier. And this creates a trap that so many non-techies fall into: beggar prompting. Asking, "Can you please clean this file?" Sure, it's polite, but it's incredibly vague. The AI basically has to guess what clean means to you. Instead, you need boss prompting. You must be assertive, give exact constraints, and demand specific final formats. You don't ask it to clean a file. You command it to extract the vendor names and output them in a comma-separated list. Shifting to this instruction-based format drastically narrows those probability tables and instantly boosts accuracy. Remember, you are the boss. Act like it. Let's look at Section 5, Pro Prompting Hacks. So how do we actually put this boss mentality into practice? Consider this exact prompt. Act as an objective, analytical business coach. Create a side-by-side comparison table detailing the pros, cons, and long-term trade-offs. I call this the Explain My Options hack. Instead of lazily letting the AI make a choice for you, which, by the way, can trigger those hallucinations, you use this prompt to shift the heavy cognitive load of structuring and organizing data entirely onto the AI, all while keeping yourself firmly in the driver's seat for the actual final judgment. Building on that, we have the persona or role-playing hack. Telling the AI to act as a Michelin star chef or a Stanford career coach, that isn't just a cute party trick. Mechanically, it conditions the neural network. It actively restricts the AI's vocabulary, forcing it to pull responses only from the most authoritative, domain-specific subsets of its training data. Pair this with chaining prompts. Instead of just stuffing a massive project into one confusing prompt, break it down sequentially. Step 1, brainstorm. Step 2, outline. Step 3, write. Chaining totally prevents the AI from getting confused by massive instructions and basically guarantees a superior outcome. And finally, Section 6, the no-code pipeline. Now for the climax. Traditionally, low-code platforms like Zapier acted as digital glue. They connected your passive apps using back-end APIs. But guys, we are currently undergoing a massive paradigm shift. We're moving beyond APIs entirely. Enter autonomous AI computer use agents, like OpenAI's Operator and Anthropic's Claude computer use. These agents don't just quietly connect apps behind the scenes anymore. They can literally see your screen, they control your computer's native graphical interface to automate your daily chores, shopping, and booking, completely on their own. Let's look at how these agents actually pull this off by mapping them onto a simple watcher, thinker, doer pipeline. The watcher detects a passive event, like getting a new invoice email. To interact with it, the agent relies on a screenshot action loop. It takes a screenshot of your screen and normalizes it into a 0 to 1000 coordinate grid. Then the thinker step predicts exactly where to move the mouse or what to type based on that specific grid. Finally, the doer executes the click. It can literally open an email, see the invoice, click to download it, open up your accounting software, and type in the data, just like a human would. But I do have to warn you, this incredible power introduces some critical security risks. If an agent is reading your emails and clicking links for you, it is highly susceptible to prompt injection. That's where a malicious email could actually trick your AI into taking harmful actions on your machine. So you absolutely must use these native interface tools with strict oversight. Well, we've covered a ton today. We went through answer engines, multi-step reasoning, boss prompting, and the incredible, if sometimes risky, frontier of autonomous computer use agents. So I want to leave you with one final provocative thought. Look at your own daily digital chores right now. Think about the tedious, repetitive clicks you do every single week. Armed with these everyday AI hacks, which one are you going to automate first? Thank you so much for joining me on this explainer. Get out there, take command of your AI, and I will see you next time.